Hi. So what I have here is a Apollo Saturn stack, uh, built-in Kerbal Space Program, um, out of a bunch of the Making History expansion parts, which are designed to look uh, like uh, Apollo and Soyuz and Gemini launch vehicles and spacecraft. So it looks very nice and very scale and like a Saturn V. And so I thought I would talk about the abort modes, because there's two of them, and the reasons why there are two are kind of interesting, and it's fun to watch them. So first off, I'm going to demonstrate the sort of, um, I guess, there's not a normal abort mode, but the one that happens earlier. So that's going to happen using this solid fuel launch abort escape system. So that's a solid fuel rocket motor. It sits on top of the capsule, and in the event of a catastrophe, it will separate the capsule from the booster. Right, so let's say, we're taking off here. Nice, beautiful scale takeoff. Same thrust to weight ratio as an actual Saturn V, so it takes off at about the right speed. Watch the shadow climb up towards the VAB there. Okay. So then, let's say though that something goes horribly wrong on our ascent. So let's say, for no reason, that a second stage engine is erroneously fired. Oh my god! And in just a second here, with any luck, the vehicle should explode. It's actually not, but alright, let's just activate another one. Alright, well, let's go instead to this other failure mode where, let's say, the guidance computer fails, and oh my god, the booster is spinning out of control. Whatever can we do? The lives of our brave Kerbinauts are endangered. Well, we can hit the backspace key, and watch it, it'll happen real fast. 3, 2, 1, abort! Fool. All of a sudden, clear the booster very quickly, very fast burn, extremely useful at low altitudes and uh, relatively low speeds, although it can handle pretty high speed. Uh, Abort, and then go ahead and ditch that tower, deploy parachutes, and splash down just like normal. Okay, so that's kind of the more obvious abort mode. Um, but it's actually arguably the more complicated one because it requires an extra abort system. But it has the benefit that it works extremely well at low altitudes, right, where you really need to get clear of the booster in a hurry, because like maybe, or if you even maybe have a failure on the pad, right, you really need to get clear in a hurry and get enough altitude for the parachutes to open. And also, that rocket motor works very effectively at sea level, warp to sunrise, so that we'll be doing this on the sunny side of the planet. We go off to the east. So there's another abort mode that uses the Service Propulsion System engine, which in Kerbal Space Program is called the REJ-10 Wolfhound. So let me talk while we're on our ascent about why we have this other abort mode. So it exists basically because of two things. One is this engine doesn't provide very much delta V, right? It's a pretty powerful motor that only fires for a fraction of a second, like you saw, and that's nice for getting clear of the booster while you're down low. But once you're in space, this engine actually is better. So solid rocket motors work great at sea level. Usually they have relatively small expansion nozzles, very high thrust to weight ratios, but they're not very efficient. Whereas by contrast, this engine is designed not just for an abort, but to actually be used for propulsion, so it's relatively efficient. The Wolfhound in game is extremely efficient, and the actual Service Propulsion System engine was pretty good. And it actually provides some maneuvering options. The other thing is, of course, because it's not the launch abort escape tower that's added on top, it's actually preferable because you don't have to carry the extra mass. but you just cannot use it at sea level because this engine is really optimized for vacuum, and it also doesn't get the spacecraft clear of the booster and gain in as much altitude as quickly, right? So it just really doesn't work at low altitudes, both because the engine itself doesn't provide enough thrust because it's optimized for low pressure environments, and because it's not as high a thrust to weight ratio, right? It's designed to accelerate the spacecraft, not super slowly, but at like half a g or something like that, instead of this that pulls like maybe 5 or 6 Gs for a fraction of a second, whereas this is half a G, but it can burn for several minutes. Oh, so almost time for staging here. Okay, so let's watch my awesome Sepratron ullage motors here. And then right before they're about to run out, let's write the second stage motors and turn probe radio. Okay, so we're going to have to get closer to orbit, but let's go ahead and... I'm actually going to leave the launch abort tower on. This is normally about the point where you would realistically ditch it, but I want to get a little bit, going a little bit faster. By a little bit, I mean actually about 1,000 meters per second faster. But then I'll show why you wouldn't actually want to use this solid motor, right? So once you're up in orbit. So one thing is just its extra mass, right? So there's no sense in carrying it all the way to orbit when once you're in a vacuum, like we're already up, the pressure is basically already zero. We're out of the atmosphere. So now this engine would work fine. And also, we have plenty of altitude now, so there'd be plenty of time to open the parachutes. And getting clear of the booster, it's always better to have more thrust and accelerate faster. But once you're in space, there's still, you still want to get away from an explosion, but it's less likely to have the kinds of catastrophic failures where the atmosphere really puts a lot of pressure on the booster, and it can, disintegrate things very quickly. Whereas in space, you're more likely to have, I mean, not a lot of time. It would still be pretty much an automatic, process. That's why I'm not going to press the abort key now, but you see when I press the key for the other abort mode, it happens quickly. But you don't need it to happen as quickly, right? You don't need to instantaneously be pulled away from a, fireball and that you're being pushed into by air pressure, right? Everything is out in space and kind of goes out in every direction at once, and there's no onrushing air pushing the capsule back down towards the fireball. So it's fine to have this smaller engine. But once we get to, I'm not doing a very good job of getting into an orbit here, but that's because it doesn't really matter. This thing has such massive excess of delta V, and also, incidentally, I can't show it now because they're almost depleted, but I actually drain about half the fuel out of these tanks. The reason is to make it look more scale. I could use a smaller fuel tank, but the second stage is supposed to be liquid hydrogen, and Kerbal Space Program only models one type of fuel. It's just called liquid fuel. And hold on, let me throttle down here now. We're getting close to the orbit. And so the second stage is actually supposed to be liquid hydrogen, which is a lot less dense than kerosene. So even though it's about the same size as the first stage, it is supposed to have actually considerably less total fuel because the fuel is so much lighter. It takes up much less, or it takes up much more space for the same mass of fuel. So what I'm trying to do here is get a periapse that's up outside the atmosphere, because that's basically the other problem with this launch abort tower, which is it doesn't provide you with any maneuvering options, right? So once you're in space, this engine can both get you clear of the booster and then subsequently be used to adjust your orbit and do a deorbit burn. Versus with this thing, all right, let me show how it could actually get you stranded in space. So let me get a periapse that's just outside. In reality, the second stage actually wouldn't actually boost you to speeds that are quite high enough. Actually, a little bit towards. Actually, I want to cancel out some of my vertical speed so I don't enter an escape trajectory before my periapse is outside the atmosphere. There we go. All right. So, all right, it needs to be 70 kilometers or higher for Kerbin. I think no, my Apple apps can get up to like 10 megameters before they can be like 1,000 kilometers before I'll actually know the escape trajectory. Um, I just did not. Oh, there we go. All right, 80 kilometers. That is perfect. All right, so let's go ahead and save at this point. So by this point, we would have jettisoned the launch abort escape system, so it's gone. And we would use the other abort mode, which is actually should have demoed these in the other order, but it's fine. So now we'll press the abort key, which is backspace. Let's say the engines were still running like this, and we do backspace. Oh shit. Sorry, I forgot there. Right, that triggers the conventional abort mode. But this is why we quick save. So now I will actually demonstrate them in the correct order, I guess, before I jettison the tower. So let's say I was up in this orbit, you know, and all of a sudden we need to abort. So we're still throwing clear of the booster, but now look at this. It actually raised our Apple app, so now we're actually stuck in space, right? So maybe we got clear of the booster explosion, but we have no ability to maneuver. We have these little RCS thrusters that are for mostly moving us, laterally. But if say we turn this way, we could actually use them to try to deorbit ourselves. So, but let's see, how fast is our periaps dropping there? Right? Actually, let's ditch this solid motor because it's extra weight. So it's like, I'm firing these RCS thrusters, so I might eventually be able to slow down enough that I could, over the course of time, aerobrake. But for all intents and purposes, it's like, and if I were in a higher orbit, that wouldn't even do anything. I could actually probably completely deplete the monopropellant supply, but that would take a long time, right? It's using it pretty slowly, but you can see it's not realistically gonna. It is dropping our. Oh, that's the wrong way. It is dropping our periaps, but you can see even if I used all of this, it probably still wouldn't get down back into the atmosphere. So using the launch abort tower at a certain point actually becomes really dangerous because you can end up lost in space without any maneuvering options. Versus instead, let me show you if I do the proper high altitude abort mode. So let's go ahead and ditch that solid motor again. So I have to remember it's the 0 key for this abort mode, so 0. And it's not burning any gas. Okay, that's embarrassing. So yeah, this game is buggy AF, and unfortunately that engine is not running. So yeah, this was all a waste of time again, and I probably won't upload this, but man, that is truly an embarrassment. So all right, so it's future me, and I actually did figure out why the Wolfhound wasn't getting any fuel, and it is a bug with the game, which I did figure out a couple of solutions to. And the one I'm using here is just to basically add more fuel tanks, because I actually want to do a test to prove that it was the service module that they added with making history and not the use of those little fuel tanks or the engine. So yeah, now let's watch a proper... Yeah, there we go. So you see that actually it does clear the booster pretty quickly on that engine. Not as fast as it does on that solid engine. There we go. See how much nicer that is? Clear the booster in space with a nice engine, lots of propellant. And in fact, this is actually, if you see that white, yeah, so see, we're burning gas pretty slowly, and this is even maybe like 10% of the fuel it was supposed to have. Maybe 20%. Because it's just that little, yeah, that section at the bottom has the same gold foil coated tanks there. So not that much gas, but more than enough for a deorbit burn. And you can see that's what I just did there, is I turned retrograde and did a deorbit burn. And then here I'm separating because now the periapsis is only 18 kilometers, so that's very comfortably going to be a reentry, like a trajectory that will induce reentry. Because before we get anywhere near that low, we'll start losing energy to the atmosphere. And here you can actually see another bug, where there's those RCS thrusters that look like they're attached to the service module, but when it decouples, they're just randomly floating there. But actually, there is actually a way that we could still deorbit this one, which is actually that this has a lot more RCS propellant. So I actually can because this thing is full of Um, there we go. So this thing is full of both fuel and monopropellant. So these are the gas tanks which are supposed to fuel the engine, but this game is extremely buggy, so uh, it doesn't always work. So let's just push ourselves away from the booster. But it also has these monopropellant tanks, which are really big. But you can imagine at a certain point, like, basically just throw ourselves away from the booster with this engine. So this actually does have enough monopropellant that I could just sit here holding the... And you see it has much bigger RCS thrusters too. But here I actually could just hold down the RCS key, and I could actually, with enough patience, just deorbit myself on the RCS. Okay, so feature me again with some extra comments real quick. So one is actually, this is how SpaceX and others actually do deorbit some of their spacecraft, is they do just use the RCS and a lot of patience because, I mean, spaceflight things happen very slowly and they just sort of deal with the delay. And the other is, I guess, I want it to be clear. Anytime I say fuel or gas, I guess I technically mean propellant. So a combination of fuel and oxidizer, or some other propellant like the monopropellant, which is implied to be something like hydrazine that just decomposes catalytically. But especially those foil tanks look even like external aircraft fuel tanks, so they're bags of gas. But anytime I say fuel, I mean propellant, and then monopropellant is the propellant that is specifically for the tiny little RCS motors, which you actually can use to deorbit with enough patience. And in fact, if you don't have a big engine like that, that's a more effective way to do that. They're not very efficient engines, but you don't need much delta V, and they hardly weigh anything, so you're still better off with just putting a little bit of extra monopropellant, or in the case of SpaceX, they use hypergolic bipropellants. Um, but lower performance engines, but that's fine because there's just, you can just replace the extra mass of a heavier engine with extra propellant instead, and it's a little bit less efficient, but you still come out on top compared to adding a big heavy engine to deorbit when you don't need that much delta V. And they basically do exactly what I'm doing right here, where they just use those tiny little thrusters with it's nitrogen tetroxide and I think monomethyl or maybe dimethyl hydrazine that they use in those thrusters. So anytime I say fuel or gas, I mean propellant, and monopropellant is propellant specifically for the RCS little tiny engines. And yeah, so actually this is not a totally unfeasible way to do things. It's just that I should have access to that Wolfhound service propulsion system engine, so it's frustrating. Anyways, um, and I'm very frustrated with this game right now because I tested this 3 times before recording, and then I even reset it because the first time failed. But they added this part specifically so you could do this, so you could have these sort of these little fuel tanks along with a bunch of other accessory equipment in a Apollo style um, service module. But it doesn't always actually connect the fuel in here to the engine. Um, yeah, see, but you can see that now now I haven't used any of the capsule's monopropellant, and I have to, this thing, yeah, you can see I've used about half of it, and now periaps is down, uh, actually not that much, but yeah, actually, so you can see if we get it anything below 70 kilometers, that would actually be deorbiting. Um, Man, I am really bummed out actually that this engine didn't fire because like I've done this like 3 times now, and it just keeps not wanting to burn the gas that's in this stupid service module. Whereas if you just put a normal fuel tank on there, it works. It works fantastically. Um, yeah, all right. Even though it's stupid, but I wasted too much time on this already, so we're actually just gonna hold down. Um, so let me. All right. Yeah. So yeah. So this is definitely going to get us below 70 kilometers, but it's just kind of ridiculous. In fact, we can get pretty low on this monopropellant and then stage off the service module and use the rest of the monopropellant in the capsule facing sideways to get our periaps even lower. But anything below 70, we can start aero braking and technically go home. But the point was to demonstrate, so in some sense, this actually does demonstrate, again, the problem with using the launch abort tower at altitude, which is a lack of maneuvering options, which I should have. It was unfortunate this doesn't show, and I'll probably re-record later. As you can actually see that this engine gets you clear of the booster pretty fast once you're in space. Um, you know, I am so annoyed that it is not getting fuel. All right, there we go. That's under 7 kilometers. We're not even out of monopropellant. In fact, let's get it to 69 kilometers. It's a nice thing, at least the RCS is nice and precise, so we can get it right to, there we go. Oh, there we go. 69.0071 kilometers. Okay, so that would actually re-enter the atmosphere. In fact, if we keep going, it'll actually get low enough into the atmosphere that it'll really aero brake pretty aggressively. But we're not going to sit here through all that. So, anyways, sorry that you didn't get to see how fast, because it really clears the booster pretty fast on this surface propulsion, the Wolfhound in the game, the surface propulsion system. So anyways, that's why there's 2 abort modes, is, one, this actually works perfectly well once you're in vacuum, and there's no sense in space, which is a vacuum, and there's no sense in carrying the extra mass of the launch abort system with you. The other reason is the launch abort system can actually leave you stranded in space. So now we would actually deorbit, in fact, deorbit pretty comfortably, but that's because I have the propellant in the surface propulsion system, even if I have to use the RCS, because this stupid game isn't feeding all of this giant collection of fuel. Look at all this gas, and there's actually, it's not just these foil-coated, like baguette, quote-unquote, they're called baguette tanks. It's not just these tanks, there's actually a central big fuel tank in there too. Yeah, that has 200, these each have 30 fuel in them. Central one has 200, and it's not pulling fuel out of any of them, because this game's buggy and stupid. But anyways, that's why there's 2 abort systems. You don't want to get lost in space, or stranded in space. I'm not Scott Manley, but nonetheless, fly safe, everyone.